4 meters that way and I go 3 meters that way, what is my displacement now? Who's up?
5 meters? 5 meters?
That would be the magnitude of, so we'll put that off to the side. So the magnitude of my displacement is 5 meters. And the distance traveled, what's the distance traveled?
A total of 7 meters.
Okay. All right, but what's my displacement? We're piggybacking on what Musa said. If I just said my displacement was 5 meters, that doesn't tell you where I am. That just tells me that would basically create a circle around my starting point. How about someone just describe in words? If I walk this path, describe in words what I did. Chloe?
Going like 4 meters to the right and then 3 meters back. Is that
Back's a vague word.
okay? I guess that's it.
Yeah, we'll go with that.
Okay.
All right, so my displacement, 4 meters to the right. Or you just said right, so that, I think it's to the is implied. 4 meters right, and 3 meters up. Obviously, what's the problem with this answer? I mean, it is correct, but what's the problem with it?
You can't travel upwards.
Maybe you can't travel upward. It is possible, I mean.
Okay.
Although 3 meters would put me into the ceiling. Think about physicists, what do they really not like to do? So we need some way of replacing those words. Well, and's the easy one to replace. Put a little plus sign there. But if I'm dealing with 2 dimensions, I can't get away with just, well, that's positive and that's positive, because then I'd have positive 4 plus positive 3, which doesn't really capture what's happening. All right, anyone feeling more confident who was sort of suppressing themselves?
4 meters east and 3 meters north.
It doesn't replace the words, actually it's more letters. But that also potentially is acceptable if we define what the north direction is.
Very high.
So we introduce this idea of the unit vector. It is a vector. It's a specialized vector. It is a vector, so it has a magnitude and a direction. For those who have not taken physics before, this one's for you. What is the magnitude of a unit vector? We're looking for a number. Somebody just whispered it.
1.
There we go. The magnitude is 1. There are no units associated with it. It is just 1. Or if you want to create a unit vector with units, then welcome to senior or graduate level physics. Beyond the scope. The direction of a unit vector, for the ones that were mentioned, the I hat, J hat, it's whatever I say it is. What I say it is, or what you say it is, depending upon the situation. So in a situation like this, I'm going to say that to the right is I hat, and hat is that mark right there. And let's say maybe this class can do it because I keep forgetting what it is. This is a critical mark, or diacritical mark in French. What is the name for it? Okay, then we will stick with hat. I mean, we're going to go with hat anyway, but I still keep forgetting what the French word is. If you're using OpenOffice or LibreOffice for equation editor, hat is the key word there to put that symbol. And J hat. Oh. Now let's see if you were paying attention. Why is I hat that way? No, not the reason.
Because it's an x-axis.
No.
We just decided that?
Oh, much closer, more specifically. I decided that.
Okay.
Did you want it the same way too? Did you also said I hat that way?
I was waiting until you did it before I wrote it down.
Okay.
Yeah.
Now, if you want to make I hat go that way, that's fine. I would not recommend making I hat at some strange angle. But. Now, the reason why I shy away from the X thing, if I hat is always in the positive X direction, and J hat's always in the positive Y direction, you are going to make later analysis far more difficult. There is a video that is posted in, I think it's chapter 4, Box on Ramp Problem Solved the Hard Way. For those people who want to stick with the brainwashing of the math people, we will break off from the math when it comes to certain things, and that's one of them. It's not always positive. Sometimes we want that to be positive. So in this particular case, to the right is I hat, so I would just write 4 meters I hat plus 3 meters J hat. So that's how you deal with 2 dimensions. Now notice when I put these together, I'm adding 2 different vectors here. I have a vector to the right and I have a vector up. When I added them, I put them head to tail, right there. And that's basically how you add vectors graphically. And we will recreate that in a moment. So if I travel in that direction, then I travel in that direction, and then I travel that way. So I've got 3 different displacements that I'm adding together. I would just connect them head to tail. So I take that and I move it up to here. Those 2 vectors should be the same magnitude, same direction. That's what makes them equal to each other. Then I take this one. It'd be better if I did one-handed. There we go. Now at this point, I'm not done. If I said add those 3 vectors and I just did that, that would be the equivalent in scalar math of saying, if I said what's 2 plus 3, and you said 2 plus 3 equals 2 plus 3. Yeah, it's not wrong, but it doesn't actually answer the question. My ultimate displacement for the entire trip is from where I began to where I ended. That line right there is my sum in red. And the sum of vectors is also known as the resultant. If you've watched the video on vector notation, you'll notice there's the double print. This is the one time I used double print for whatever childhood trauma caused it. That's the symbol I use for resultant. If you really don't like the double print and want to just do a capital R with a vector symbol over it, that's fine too. All right, questions up to here?
On
Yes,
the
Sarah.
I and the J hats, why
Yep.
did you connect them tail to tail and not?
I'm indicating direction, and just like generally coordinate axis, they're
Okay.
perpendicular to each other. Sometimes I'll even put that there to just emphasize
Okay,
the fact that.
so it's not like quite the equivalent to what you do on the left.
Right, right. I
Okay.
could have done I hat like that, and then J hat like that, and take up more
Okay.
space.
Okay,
But
that makes sense, thank you.
anyone want to take a wild guess if we went to a 3rd dimension, what we would call it?
K? K hat?
There we go, yep. Some textbooks will stick with X hat, Y hat, J hat, or, sorry, Z comes next, Z hat. Just not a fan because that still keeps us in the mindset of math. I should say math brainwashing. All right, so this is a vector right here. This is in rectangular coordinates. Or rectangular form, I should say. I think it was Musa who said 5 meters before. I was giving you credit for it, when the 5 meters here.
Oh.
Recognize if those are perpendicular to each other, and that was the intent, then my resultant that's my resultant. The magnitude is 5, Pythagorean theorem, but I somehow indicate the direction. Now with I hat, J hat, I get to decide what the direction of I hat and J hat are. It is understood if that direction is I hat, that way is negative I hat. So I don't have to say which the negative direction is, it's just opposite. But if I'm doing this right here, I have a magnitude, whatever, 5 meters, but that direction, it's some angle. 0 degrees is that way. Unless you state otherwise, it is assumed, we are sticking with the math convention, 0 degrees is that way from your point of view. 90 degrees, 180 degrees, 270, 0, or 360 or 0. Going the other way, negative 90, negative 180, negative 270, negative 360, or 0. So how would we find that angle?
Pythagorean theorem.
Pythagorean theorem just deals with lengths of sides.
I didn't hear what you said.
Oh, Pythagorean theorem just deals with lengths of sides.
Oh, okay.
Doesn't help us with the angle.
Sanchez.
Pardon?
Sanchez.
Yep. Is that what you were sending me telepathically? I'm just getting stares. No, April, yep, okay. How many of you have had trig? Right triangle trig, nothing fancy. All right, so roughly half. This is an algebra trig based class. There is trig involved. We are not getting really beyond the right triangle trig. If you've ever heard of law of sines, law of cosines, you don't have to use them. If there's a situation where you can and you want to, sure, go for it. But there's no problem where those will be required. If I have a triangle here, let's just say it's a 3, 4, 5 triangle. Make it a right triangle. And I have another triangle here that's a 6, 8, 10 triangle. These are known as Pythagorean triplets because 3 squared plus 4 squared equals 5 squared, and 6 squared plus 8 squared equals 10 squared. Is geometry taught anymore? How many of you have had geometry? An even smaller group. Wow, okay. If you have triangles that basically the ratio of sides match, so this is twice that, that is twice that, that is twice that. These are known as similar triangles. And one of the other characteristics of a similar triangle is that the corresponding angles match, that this angle here, we'll label it theta, and that angle there are the same angle. this angle up here, which I'm gonna label as theta prime, and this angle right here, which I'll also label as theta prime, are the same angle. Those angles are the same, those angles are the same, and those angles are the same. So for similar triangles, not only do the sides are proportional with the same constant of proportionality, so each of those sides times 2 gets me this, but the angles are the same. And that's the essence of trig, right there. So if the sides are proportional, then if thinking about this angle right here, so imagine you're in a room with 3 sides, 3-sided room. The opposite side is the one that you're facing. If you're standing in the corner, opposite is 3, divided by the adjacent side, and the adjacent side this is known as the hypotenuse. So the adjacent side is not the hypotenuse. So the ratio of this to this is the same ratio down here, 6 to 8. And so that ratio is the same, and so they decided to give it a name. They call that the tangent of theta. Tan for short. If I did the opposite side over the hypotenuse, well, that's the same as the opposite side over the hypotenuse here. Those fractions are equal, or the math people have been lying to me really badly. And they call that the sine of theta. And then if I did the adjacent side over the hypotenuse, this 4 over 5, well, that's the same as down here is the adjacent over the hypotenuse. And that's the cosine of theta. But we have to somehow solve for theta. We're still solving for an unknown here. So if I had 5x is equal to 4, how would you solve for x? Yeah, you got to get rid of everything that's not an x from one side and get it over to the other side. Except tangent of theta, they're sort of linked. That's a much stronger bond. It's not tangent times theta, it's tangent of theta. So we need to somehow undo it. We have to somehow get rid of tangent. And we do that by doing the opposite, or doing the inverse. The trouble I have with that term is that inverse sometimes also means the reciprocal. That would be the multiplicative inverse. Additive inverse, it would be the negative. The trig inverse is a little bit different. So we have 0.75 is equal to the tangent of theta. The opposite of tangent is, or the inverse of tangent, is the arctangent. So I'm going to do that to both sides. And arctangent and tangent will cancel each other out. And I'm left with theta on the right, and on the left, I'm left with this. Since half of you have not had trig, I don't know if you've played around with those buttons on your calculator. I'm willing to bet none of you have a calculator that actually says arctan. My calculator does atan, which is what I tend to write on the board instead of writing out arc. I just put an A in front of it. But I'm willing to bet almost all of you, if not all of you, don't even have an atan button on your calculator. You do?
I do not,
Oh.
but is it like, is it tan to the -1?
Yeah. Most of your calculators will have a -1 there. So if someone would be kind enough to actually tell me what the arctan of 0.75 is,
36.87 degrees.
Anybody come up with a different number when you plugged in? Like come up with something closer to 0.5? You have 0.64? Are you in radians? If you end up with something other than this, if you end up, I guess, at 0.64? Potentially that's radians, that's a different unit system.
Okay, we're good now.
Good. We will be dealing with degrees, and this messes some people up because in math class, they're doing radians, and then you come over to here and they forget to switch the calculator over. Just please be aware of that. We will deal with degrees for most of the course. When we get into some of the stuff near the end, we'll be using radians. So units are important here though. Degrees, you put a degree symbol there. Radians, if you want to write rad, that's fine, or not. Or if you want to write it out. We'll talk about it in more detail later, but radians are sort of a unitless unit. You can put it in if you like, or don't put it in if you like. So if you tell me an angle is 36.87 and leave it there, you're telling me radians, if you don't put units on the angle. Now, over here, we could have solved it with, we had the sine of theta is equal to 0.6. So theta would be the arc sine of 0.6. And if you plug that into your calculator, I hope you get the exact same thing. Let's just get confirmation that you do. Or theta would also be the arc cosine of 0.8, which again, better be the same thing. Questions up to here? Let's get rid of some of the old stuff.